First is, I'm gonna do a couple of things this morning before you all get to work. I'm going to go through the whole project, the Phyla collection project again, briefly, so that you get a big picture. I want you to have that big picture in your brain, but I also know that what we really need in the context of a beginning biology class in high school is something that is more structured and sort of built for a day-by-day thing. Like, this is what you're going to do today, and this is what you're going to do the next day. So you'll get both of those things. Big overview, which I think for many of you is a little too much to take in, but it's nice to just, the more you hear it, the more concrete it will feel to you. And then I'll go through the specific tasks for today. There's really just a few tasks for today, and I will, all of the information is on campus as always, and I will be here to help you as always, and what I'm going to ask you to do today is highly doable for anybody who uses their time well. Before I go through that stuff, I have one major logistical announcement to make, and it's going to take you guys a while to get used to this. Not my call, but I don't know whose call it was. Somebody decided no more lock on this outside door. So what that means is that I cannot just leave it ajar all the time for you all to use as a convenient way to get in and out of the classroom. And that means that there are going to be times when you are outside that door and you just can't get in. And the way it's going to work, and this is not because I want to be a jerk about it, but it's because I will not be able to be a door opener. If you come to the door and nobody lets you in, then you have to find another way in. If I'm here and I'm talking and I see you and you stand at the door and you do this and I don't let you in and nobody else lets you in, don't knock, don't stand there. You're gonna have to find another way in. My goal would be to have anybody who needs to get into the building once the doors have all been locked go up to the front office and interact with the people in the front office. Because what I think is that we need to, this whole system of locking doors for most of the day is not great. It's not convenient, not convinced it's making anybody any safer. It's making some people feel safer. That is really different from being safe. Morning. Locking the doors is kind of like putting on a seatbelt while you're riding a bike, right? Like, you're like, okay, I'm all seatbelted in, but the thing about bikes is staying attached to the bike during an accident doesn't actually make you safer. That's not the problem with bikes. In cars, it's different. In cars, the reason you wear a seatbelt isn't to keep you from flying out of the car. It's to keep you from flying into something else in the car. The windshield, the seats in front of you. There's no windshield. There's no seats in front of you on a bike. You could put a seatbelt on a bike, but it won't make you safer. The way our brains work, the way people process risk, is we think about things like, well, if there were to be something bad that happened and the doors were unlocked, then there's something we could have done to potentially prevent that bad thing, which means it's the door's fault. That is faulty logic. It makes absolutely no sense. That's not how things play out. There's no statistical association between horrible things happening in schools and whether or not the doors are locked or unlocked. What we need to do is come up with a more sensible way of trying to keep people safe. And I think that is most likely to happen if every time people need to get into the building, they go to the front office. If you go to the front office every single time you're locked out of the building, eventually the people up there and or your parents will start to realize, holy cow, this is not a campus where we can just lock the doors. This is not the campus for that. Some campuses you could do that. You have one of the elementary schools where the kids are inside and they're all in the same building, then that works. Because once you're in the building, anything you need is in the building. But here, we have all these separate buildings. You need to go to your locker. Guess what? You're locked out now of everything. You leave this building and you have to get into the main building through the office. You go to your locker and then you have to get back into this building through the office. It's silly. That's what I think we're going to need to do. We need to like make it clear that things need to change. Okay, so we'll talk more about that. I know it's going to be an inconvenience for a lot of you, and I'm really sorry about that. I have no interest in causing trouble for you, but that resource has been taken away. All right, so let's talk about our Phyla collection project. So again, I'm just going to give you an overview, and the overview is that at the end of this semester, you're going to have some stuff. You're going to have a big plastic bag, and inside that plastic bag, you're going to have ideally 12 smaller plastic bags. Inside each one of those smaller plastic bags, you're going to have a specimen card, and you're going to have a part of an organism that you have collected, probably here on CV's campus. In some cases, may come from somewhere else. And each one of those 12 specimens will be a representative of a different biological phylum. Phylum is just a big group, right? And the organisms in a phylum are all related to each other in some way. They are genetically, evolutionarily similar to each other in some way, but they're big groups. So for example, our phylum is phylum Chordata. We are in that phylum along with chimpanzees and gorillas and chickens and salamanders. Like all of these organisms are members of the same phylum. Most of the plants that we looked at this year and most of the plants that you see outside are all members of the same phylum. Was that enough? Amazing me right getting that. This is going to be a learning curve. Hey Sam. So what that means is that you need to be able to find 12 organisms that are all members of different phyla. We talked a little bit about that on Wednesday, and I'll give you some more examples today of what that would look like and how you can do it. It's not that hard. It sounds like a lot because you all don't know the different phyla. And so if you go outside and you look at an organism, you're like, well, I don't know what phylum this is in, so that seems ridiculous. But there's another way to approach it, which is to start with a phylum and see if there's anything in there that you recognize. And what will happen is you'll find, as you go through the list, and there's a lot of them listed there, but it doesn't take long. As you go through the list, you're going to realize, oh, I don't know anything in here, not going to use this phylum. I don't know anything in here, don't know this phylum. Oh, this, I recognize this, I'm going to use this. And so you'll be able to find your 12 reasonably quickly if you go about it that way. So you're going to have a specimen, you're going to have a specimen card. This is primarily what you're going to work on today. Your big priority today is to start working on these specimen cards. You won't finish them, and we'll have more time next week to work on them on Monday. But this is your big job today, is the specimen cards. There's also going to be a couple of other things that tie into this. One thing you're going to do is you're going to make a phylogenetic tree, which we talked about, Mr. Fiskin talked about a few weeks ago. That's the branching diagram that shows relationships between organisms or groups of organisms. In this case, what you're going to show is the phyla. You're going to show how the phyla that you used are connected to each other from an evolutionary sense, and you're going to show the really key characteristics of organisms in that phylum. So for example, our phylum, which is phylum Chordata, the really key characteristic of that is a spinal cord or a predecessor to a spinal cord. We are chordates because we have a cord that goes right down the middle of our body that provides structural support for muscles and skeletal pieces and all that good stuff. So that's why we're in the same group as chickens. They have a spine, and salamanders, they have a spine. And anything with a spine, phylum Chordata. So we're going to be looking at those like key characteristics of the phyla, and those really are like why we group things together the way that we do. It's those key characteristics that cause us to group things together. So that's going to be your collection, and that's going to all be in this plastic bag. And then there's one more piece, which I'm going to ask you to do, and that is I'm going to ask you to give a short presentation about one of your organisms. And we'll have time to prepare that, not next week, but the week after. And then you'll give your presentation to the class with your partner if you have one. It'll be quick. We're going to focus on the interesting stuff. It's not designed to be something that is humiliating or embarrassing or like points out things that you're not good at. It's designed to be an opportunity for you to share briefly what's cool about one of the organisms that you collected. That's the big picture. Today specifically, what I'm going to ask you to do is work on these these specimen cards. And this is what they're going to look like. And this is in the main document, which is posted to Canvas. It's also in today's module. So if you click on the assignment for today, I've cut and paste that exact same depiction of a specimen card. And I have note cards for you up here that you can use. And there's a bunch of information here. Some of the information you're going to be able to fill out today, and that's what I want you to do. I want you to start today for all of the organisms that you found on Tuesday, I want you to start by making sure you know exactly where they are on campus, right? So step one is locate, but don't collect. You're not collecting anything yet. That's not going to be till next week. But today, you're going to make sure you can find them. You might have been able to find them on Wednesday, which is great. If you know where they are, you don't need to go out and look again. Thank you. But if you, I think that's right now. If you put something down, if you were like, oh, I know there's turtles on campus, and then you're like, I'm going to go collect a little fragment of a shell from a turtle egg. That's going to be awesome. Well, if you haven't seen turtles and turtle eggs and fragments of shells from turtle eggs, then before you make a specimen card, you better make sure you know where to find them. So you're going to go out and you're going to look for all the things you listed. Nobody got 12, right? Did anybody get 12 organisms? Nobody got 12. That's fine. I don't want you to find the new organisms yet. I want you to start with the ones you already got. Maybe you got 3, maybe you got 7, maybe you got 8. I don't know how many you got, but however many you got, start by finding them here on campus. Then your next step is to prepare specimen cards. So this is only for the ones that you were able to locate. So maybe you had 8 listed on Wednesday, and then you go out today and you find 6 of them, and the other 2 you're like, geez, I thought we had dinosaurs here on campus, but no dinosaurs. So that's not going to be my phylum Chordata representative. I'm going to have to figure out something else. So now you have 6 that you know where they are, and that's where you're going to make your specimen card. And your specimen card will have some things that you can fill out today. The first thing is each specimen is going to be numbered. There's no like pattern to the numbers. It's just the card will get a number, the bag will get a number that's associated with a particular specimen. You're gonna have 12 of them ideally. Doesn't matter which one is number 1. So just figure out what order you want them to be in. You need your name on the card, the specimen, and the assignment. According to OSU, you don't need the scientific name. So common names are great, which means you could put both, or you could just put the scientific name. But if you know the common name, you're welcome to just put that. The phylum, which you should know, because you need to make sure that each organism is from a different phylum, and the collection location. And I want you to be as specific as possible, so Pleasant Valley campus, not as specific as it could be. Like by the creek next to the tennis courts, Crescent Valley campus, that's really good. On a rock in the creek, underneath the bridge between the E-wing and the F-wing, that's really good. Ideally, if you collected something from here on campus, I would be able to go find your collection location by using your specimen card. And that is probably as far as you're gonna get. And that's great. So just the top part of this card is your goal for today. The rest of it we'll be working on next week. Once you've got, and you may not get there today, and that's okay, but once you've got a specimen card for each of the specimens that you were able to locate, each of the organisms that you were able to locate, then you can loop back and pick up where you left off on Wednesday. So if you had 6 specimens that you were able to locate, then you're going to make 6 specimen cards, and if the class isn't over yet, then that means you're going to have whatever time is remaining to track down and make specimen cards for additional organisms. And that, I just want to review really quickly how to do that, because that's where it's a little weird, because a lot of you are like, well, how am I supposed to know which organism is in which phylum? And if I go out and I collect 3 plants and then I come back and they're all in the same phylum, then what do I do? And the answer is, don't start with the organism. Start with the phylum. You don't know what any of these are, or you might know a few of them, but you won't know what all of them are. So you're gonna look them up. You're gonna type in Rhodophyta. I don't know what that is. I have no idea what Rhodophyta is. Rhodophyta, I know, I actually do know what it is, but you get it. Red algae. I mean, maybe we have red algae on campus. I don't know. This is not jumping out to me as something as like, oh yeah, there's that big patch of red algae. I am, but you're not familiar with red algae, probably. Which means this isn't gonna be a phylum that you look at. So go find another one. What about Bryophyta? Bryophytes, that's weird. Bryophyta. Mosses. Has anybody here seen moss on campus? Okay, you've got one of your phylum. Now, you're good. That's 1 out of the 12. And as you go down the list, you'll find some of them, there's just no way. If you look up the beta proteobacteria, which is a phylum, you're gonna find some stuff and you're gonna be like, I have no idea. There is no way on this earth that you're gonna be able to collect and identify a specimen of proteobacteria beta. You could look it up, but what you're gonna find is you just don't have the expertise, we don't have the equipment, it isn't gonna work. But some of these things, you may not recognize when you first see them. Annelida, what's that? Let's look it up. Annelida, I don't know, that looks crazy. Wait a second, I know what that is. That's an earthworm. Again, you just found another phylum. Now, are you sure you know where an earthworm is on campus? I feel pretty confident that we could all find an earthworm here on campus. I don't know for sure. So, something to think about, maybe we'll find one, maybe we won't. But certainly, that's something that you could identify if you saw it outside. So just to recap, your goals today, you really have kind of 3 goals. 1, make sure for the organisms that you listed on Wednesday, you know where you could collect them on campus. Not just, I think there's turkey feathers out by the tennis courts, but go out and look. If you don't see any turkey feathers, then you're not going to be able to collect them. Cross that off your list. And then once you've found all the organisms that you were thinking of on Wednesday, make a specimen card, and you really only have to think about this top part, down through collection location on the specimen card. The rest of it will be for next week. And then once you've got specimen cards made for all the organisms that you were able to find, then you're going to go back and start filling in gaps. You're going to find additional organisms to try to get to 12 organisms from 12 different phyla. And as always, my thinking about this is not that if you don't get 12 organisms from 12 phyla, you are a failure and you're never gonna amount to anything and I'm gonna not pass you. That's not the point. I want you to actually enrich your own existence. That's what I want. And so what I want you to do is find some really interesting organisms, think about it, think about the diversity of life, think about how cool it is that organisms in these different phyla are related to each other, and the different phyla are related to each other as well. And use your time. If you end up with 10 or 7, but you've been working really hard, you're good. You're good. You're not going to fail by not getting all 12. If we had more time, I know everybody could do it. Under the circumstances, all I can guarantee is that everybody here is capable of working really hard, using their class time thoughtfully. So that's all I'm going to ask. All right. Does anybody have any questions before we get started? All right. Let's see what you can do. Go learn some fun stuff. Bye.